Next speakers, we have Holger from Qwello. He's really a huge open source evangelist. I've seen your list of projects that you've started or worked on. I'm impressed. I'm so happy to have you on board with EVerest. So for the people that don't know, Qwello is one of the members of the technical steering committee of EVerest. And Holger is in our technical steering committee. And together with Evgeny and Dmitry, they will present EVerest.
Sorta, yes. Okay, so here we go. Welcome everybody. It's a privilege to speak here today. It is true I am part of the technical steering committee of EVerest, but today I come as the CTO of Qwello. And together with my two colleagues here, Dima and Evgeny, we prepped a little sandwich. So I will actually, I'm the bread, so I start, I'll end. And then in the middle, the really tasty stuff is actually presented by my colleagues. Yeah, so what did we bring today? Actually, let's start actually. Who are we? Who's bringing you what? So who is Qwello? Like, hands up, who has heard of Qwello? Wow. I keep asking those questions whenever I speak. I don't speak so much for Qwello yet at this point in time, but usually it's kind of like, nope, nobody has heard of Qwello. But like, it's changing. Who are we? We actually are a charge point operator, a CPO. We only do AC. We are right now active in 6 countries, roughly 80 employees, which actually is kind of crazy to think about because 3 years ago we were like 6 or so. We primarily target the inner cities with our own hardware and our own app. And maybe to understand why this is relevant, I brought here a photo of the first gen, and we will talk about that guy in a moment. What makes us special is actually we're building our own hardware, and we optimize this hardware not for price, because we don't have to sell it to anybody. We actually optimize it for optimal operations, like good maintainability, like good times in the field, and so on and so forth. And specifically, since we target the inner cities primarily, we built a lot of features that are very useful for the inner cities. So like the Gen 1 actually is very high. That's like 2 meters 20. So you can see like the occupation ring as a driver from very far away. We have a park sensor, which is down here. So especially, like for example, in the city of Munich, it's very common that you look at your apps and they tell you, hey, go to this and this charger, right? And then you arrive there and there's actually somebody parked in front of it, but the app tells you, yeah, sure, it's free, right? We don't want that to happen to our customers and to our roaming partners, hence we have a park sensor which actually makes this impossible. And the last thing that we actually have is this cable reel. That's like a 7-meter long cable that, like the idea is basically that from arriving at the charging station to starting to charge takes you only like 15 seconds or something like that. And not having to get your own cable out of the trunk is really nice. Another thing that makes us a little special is also that we have had contactless payment in all of our chargers from the very get-go. And that's actually, it's always funny when we hear others in the industry talking about that. They say like, oh, ad hoc payment or QR code payment, it's like 2% of transactions, 5% of transactions. Not for us. For us, it's like roughly 35 to 40% of our sessions are actually done with credit card, right? So what did we actually bring today? I just talked about the benefits of our V1 charger. Actually, we brought our next generation, the V2 charger, and you can see it has a bunch of stuff that we retained and a bunch of stuff that has changed. So the first one is actually, this one is not 220 centimeters. It's hard to see, but it is not. And the reason this is not is because a lot of cities actually don't like that, right? Every driver likes that, but not all of the cities like that. This one is actually very short, so that all of the cities like it. And the other thing it is actually very compact. So all, this is like roughly 900 square centimeters of base, projective space on the bottom. And it means that all of our markets we're active, this is actually accepted, right? And a compromise that we had to make is we had to give up our cable reel, which is a damn shame because actually 95% to 90% of our sessions are done with the cable with our chargers. So really sad. We have another product in the pipe that brings it back, but obviously it's then a little bulkier again, right? And otherwise, a lot of our features are retained. So like we have credit card payment right away, we have the park sensors. Actually here you can choose where you want to install the park sensors depending on where the cars are, right? That is done on installation. And another thing that is really cool about this one is actually it contains a charger that we have co-developed with Phytech and with Pionix. Like actually it's the Fiversio, like here Martin from ChargeByte has it in his little box because ChargeByte is selling it as well. And to our understanding, it is the first commercial charger that will run entirely on EVerest. So basically everything on here is EVerest. And this one, pretty much exactly this device will go into the field in Munich in roughly 4 weeks, 2 to 4 weeks. And we will start building them at scale and rolling them out in the Netherlands starting in May. And the menu that we brought for you today, basically like the sandwich, we will talk mostly about what we had to do to get EVerest running on this device. And that actually is opinionated. We bring a few things that we brought to the table and a few things that we changed also on like how EVerest does it. And some of our experiences. It's kind of all glommed together. And then in the end, we have a little teaser, which is really, it's just one slide. It's like dessert, where we explain what we also do with EVerest or what we plan to do, because to be fair, nothing of that is fully in production yet at this point in time, which I called homogenize the fleet. And with that, actually, let's dive right in, taking EVerest into the second generation. So I talked about this guy before. We brought it here to you. I praised most of its features. So it's very compact. I put here included cabinet. In fact, this one doesn't include a cabinet, but it has a little bigger brother, which is like 20 centimeters higher, which includes a cabinet. Dual socket 22 kilowatts. Payment terminal, which also acts as RFID card reader, so there's no confusion where you have to touch your card. A nice display. Park sensors, I talked about that. Oh, that's maybe also relevant. This one actually is right now in Eichrecht certification, but we actually added a bunch of features into EVerest to make Eichrecht compliant chargers easier to build, which we also upstreamed. We will talk about this later. And as I mentioned, it's based on this Fiversio charge controller, which is a co-development between Pionix, Phytech, and we at Qwello. We also contributed a bit. Under the hood, what did we want to make different, right? Like we actually had experience with our first charger, so what was it worth to us to actually go and so drastically change the innards, right? And one of the things that we really strived for is we wanted to have like a little bit of a cleaner design. So our thinking is that like the AC charging, right, like the low-level communication with the car, with the PWM signal and so on and so forth, that is well understood, that will not drastically change. And like we learned that actually being really real-time is important. So we really wanted to encapsulate that on its own little microcontroller that is actually running independently of everything else, right? On the other hand, our feeling is that ISO 15118 is so buggy, so little understood, so much changing at this point in time, that you actually want this on a higher software level where you can make lots of changes, which actually means that if your car plugs in, like the communication, the Ethernet communication over the power line must end up on like a Linux-based computer, essentially, right? And also from experience, we really wanted to have full control over the hardware and the software stack, which in the end drove us basically towards open source and also towards this collaboration with Phytech and Pionix. Yeah, and that also just naturally led to EVerest, right? Like we wanted to do everything where we could have full control over the source, and we were already anyways talking to Pionix and Phytech, so we basically made early the choice that we wanted to be the first company that fully embraces EVerest on a public charger, and we also wanted to do it really, really fast. There were ulterior motives for EVerest. As again, it's like the teaser at the very end. I will talk about this in a moment, right? But that basically set us on this journey towards this one. And this was roughly, I want to say, maybe May, June, July of last year. And we knew that we actually wanted to get this thing out into the field May of this year. So we had to get cracking, right? Very fast development cycle. So what does actually production then mean for us, right? Like we actually think when we talk to production as a CPO and we have high ambitions, we're talking about like on the order of like 10,000 of chargers in the field, right? And in the field means in the field, right? They're all over Europe. They're far away from our offices. They're really, really alone out in foreign territory, you can think, right? They must obviously run for at least 10 years, right? We are all about making devices that are actually sustainable and so on and so forth. And a device that you have to replace every 5 years is not sustainable. We want to have them in the field for at least 10 years, actually much longer if possible. We don't want to do maintenance on them. They should just work. But remember what I said about ISO 15118. We expect that we will see lots of necessary changes there. So we want to be able to update the software on those devices at least weekly, maybe more often. And obviously, we want high uptime. We are aiming for 99% right now, but higher would be better, right? Obviously. And thinking about all of that is kind of all the product focus, right? But we also have to think about what does it mean for us as a company, right? Like in 10 years, I might not be in the company anymore, neither might be one of these guys, right? But the show must go on. The next generation of people inside of Qwello must be able to kind of take over and carry things forward, right? So we also believe that this is part also of the sustainability story and like the production story. And that means for us that we need really great developer experience and also like a building experience, like building the software, building the product, great testing, and most importantly, high confidence and correctness of our software now and in the future, right? And actually, two of the tools which we will now deep dive a little bit that we chose to do that is actually Rust and Bazel, and I kind of underlined here where I believe those tools help. And with that, actually, I give over to...
Yes, hi. I will talk, super loud. I will talk about developing the interface for Rust. Who has developed an EVerest module already? Hands, not very few. Okay. Who plans to develop an EVerest module? Okay. And who has heard about Rust? And who has written in Rust? Okay. So basically, kind of why Rust? Like Rust is a great alternative to C++, and we at Qwello use primarily two languages, which are Python and Rust. So kind of we thought it would be actually great to be able to reuse Rust when we migrate from our, to reuse our Rust code when we migrate from our current software to EVerest. So we thought actually let's try to add Rust to EVerest. And as we heard about before, EVerest is a modular architecture, so per se, it supports already, like it did already before we added Rust, support C++ as the primary language, JavaScript and Python. So per se, it is kind of easy, or kind of, it's possible to add also Rust into it. So what we did is basically added Rust as a second language which supports code generation, which basically makes it, let's say, ready to use for your project. And I want to talk about how we actually did it and what was our experience, and maybe show off a little bit the results we achieved when we did it. So what's the idea actually for adding Rust into EVerest? Per se, since EVerest is just talking to through MQTT to the broker, so we could just kind of wrote everything in pure Rust and replicate the interfaces the C++ framework exposes in just Rust and kind of be done with it. It is a valuable and reasonable approach, but we kind of decided not doing that to avoid duplication with the C++ framework. So there was talk about community and kind of keeping a project alive, and at this point in time it was the belief that kind of having a being kind of detached from the main EVerest development would not be really useful for the community. So what we did is basically kind of, this is like technicalities, but per se we just wrapped C++ code in Rust and it's also very simple to do, so just a few functions we had to handle, and by this we basically added the basic Rust support, which was like 1 week work, and this was more or less done. It turned out, this is it's very small, but basically our learnings from this is actually like first support for Rust is rather easy. What was rather difficult was making it reasonably cross-compile it, C++ and Rust and C wrapped in Rust on different platforms. So this was like a rather it was quite effortful, and we spent almost 1 developer month on just making it work. So per se, kind of like the takeaway in the hindsight, we are kind of glad that we went down this road, that we didn't just replicate the C++ framework, because we feel it is better for the community, but also given that we did it with quite a high time pressure, it might have been also still kind of like we would probably not redo it again, and maybe just for when you're facing a high time pressure, just rewrite the Mosquito clients ourselves. But yeah, this is how we get there, and maybe kind of why is it actually, like, why does it matter? Besides kind of we not only like Rust because it's Rust, but we also did a few things a little bit different, like our Rust interface, or like the Rust interface, let's say like this, it's not our, but our Rust interface, works or looks a little bit different than our C++ interface. First of all, like some things are inevitable because kind of the languages have different semantics and different rules. So, but what we actually tried to achieve for also kind of to keep it in line with what Holger said, we wanted to make it really hard to make mistakes and to make it also more or less convenient in the same time. So kind of be rather strict and at the same time be kind of make it easy to do the right things. So we kind of forced, for instance, all users to implement, like first of all, the interface looks a little bit different. So we used an like actor-style framework. If this tells here anything to someone, we forced all users to implement the callbacks. We prevent users, for instance, to publish to anything before every module is initialized, just by basically not giving them the handle to publish before the framework says, yes, everyone is ready to go, which basically kind of goes into this philosophy which we try to achieve, that it should be, like the interface should be safe enough to prevent, to guide the user into the right direction. What we also did is basically, like I presented it already in one of these working groups, and I think it's kind of should be useful for many people. We added mocking support out of the box. So right now we support in the code generation mock stubs. So when you write a unit test, you can basically have test all your code, which kind of, if you want, you can have a code coverage as high as you want. This might be actually kind of, because Rust is a very fairly new community, we probably are the only ones using it. It's also maybe a nice testing bed for C++. So if it works, maybe for Rust, we can then make it also work in the C++ code generation, which is maybe like a nice way of trying things out. This is about correctness, and like the second feature, which kind of the second, let's say, objective, the better word, is to make things easier. So right now, if people, like I saw not too many have worked with the modules of EVerest, you have to, like there is a standalone CLI, which is called EVCLI, which sometimes you need to at least I need sometimes to rerun, maybe I'm doing something wrong here, manually if I change my YAML files, something like this, so basically to re-trigger this code generation. In Rust, it is all baked in. So there is a kind of out-of-the-box support when you open up your development environment. We generate just with pure Rust tools the code generation steps, and you don't notice anything. So this is kind of one really convenient thing. And the second one is, at least for now in C++ code, you have to commit this auto-generated code to Git or your version control. And then you have some annotations where you say, this is auto-generated, this is not auto-generated, please keep this, please don't keep that. We have a kind of, at least in Rust, we managed to separate it totally, so it is, you never have to commit generated code, and you just basically, when you build it, it is regenerated every time, consistently for you. So you don't basically need to keep track of it. There is no code duplication between the generation and the YAML files which define it, and you also don't need to kind of to adjust and mark it. So this is basically Rust. I feel maybe since so few people have worked with EVerest, doesn't make sense to show some code. It's a development conference, so maybe I can show some code, but I feel, I don't know. So basically, Hopla, this is actually Bazel. This is Rust. Is it big enough?
Yeah, make it bigger.
So how does it look like, and why is it maybe interesting? Let's start with the YAML file. People are familiar with what the YAML file is? Yes, okay. So like not what a YAML file is, but this YAML file is. So, so it's basically like, it defines a very simple project which kind of has provides something and then requires something. So it requires their store, provides my store, a key value store, and provides foobar, which is an example. So it's not very, it doesn't do anything meaningful. What it is, but kind of what I want to show is basically how does the Rust interface looks like for this project. So per se, this is this build file, but it's not that important. But per se, you basically, Rust forces you to implement what is called traits. So people who work with Rust should be familiar. It's like an abstract interface, maybe similar to an abstract interface. Here we just implemented like a key value store which loads, like this is the methods which are defined in the interface, and we just implemented them. And if you would not implement them, you would already get a compile error, and the compiler would tell you you are missing, for instance, like if I just outcommented and would compile it, it should not work, and we should just see that. Yeah, so kind of it doesn't work. So it lets the developer know that he is not or she is not doing the right thing. Yes, so kind of this is one aspect. So, and as I actually mentioned, the generated part is kind of this is what we generate, and you never have to commit it. So it looks a little bit, let's say, not very readable, lots of macros, lots of details, but you never should need to read it. You just need to include it in here, and then you can just include all your generated things you want to use as a name from the namespace or the module, what is called in Rust, and you can use it. And maybe the last thing, which basically which I wanted to showcase, is actually how mocking works. So for now, at least in C++, it is not that easy to, for instance, to test a function like this, where you kind of have a callback, and inside the callback you want to say you want to republish something, which is probably a very common use case in the Rust architecture. Something comes in, something comes out. And basically with this mocking support, we can just create a mock and tell, expect that we call you and do that, and basically just call then your function and make sure that, that everything works as you expect. Yes, I am handing over to the next, which is Zhenya, who will talk about Bazel.
Yeah, So basically, let's talk about the developers' experience. So basically, we as developers were under kind of conditions that kind of we embraced EVerest, like which already supports two languages, C++ and Python, and we wanted to use it. And we added Rust, so we were actively working on modules in 3 languages, and we wanted to have a build system that actually efficiently works with all of them. CMake sort of works with it, but kind of it's very tailored for C++, but not very good with other languages. So we started to use Bazel for our builds for EVerest. So what is Bazel? Anyone knows? Yeah, few people. So basically, Bazel is a build system that was originally created by Google. They use it internally, like internal version of it. They say that it's like main features is that it's fast and correct. What we value is that it's actually scalable. It has multi-language support, and if you do it right, it does hermetic builds, which means that like all dependencies are pulled from somewhere, like from like very specific revisions, and you just always reproducibly build the same thing if you use the same code. What else we get from it? Kind of basically it's about speed as well. So basically Bazel is very efficient in caching artifacts. It knows like kind of what it can reuse, what it cannot reuse. So basically all incremental builds are very quick. Like if you did a small change, you get updated build very quick. And it's structured in the way that like description of our projects is separated from the way how you build it. So basically the same source code, the same kind of build files can be used for cross-compilation for different targets or for local development and running. Because EVerest was not like originally developed with Bazel and didn't have support, so like we had to integrate it somehow. And how we did it, we added Bazel annotation for very essential parts that we're using, like mainly for framework and Rust bindings that we introduced. And these annotations we used, like we referred as external dependencies in our code base. So basically, we were pulling EVerest core and Rust bindings from main EVerest repository into our internal repository and build on like locally. For target compilation, because like of this Yocto and how we built EVerest for Yocto and so on, we decided to do slightly different way to speed up the process and simplify our life. We actually did a like Yocto build of EVerest with all the modules baked in and use this as a sysroot for cross compilation. So basically, compilers were going and finding libraries of EVerest as well in the sysroot. But like for developer, it was a seamless experience. So basically, compiling for local or compiling for target system, the binary was about switching the configuration of the Bazel build. So basically, what impact we had is that like we were like a relatively small team, with just like 7 developers working on kind of building software for this station. We developed 7 new modules, and we actively contributed to 2 other modules for iHext support. And last month, of like before we kind of make a
integrated with a new meter, and that is also in the process of being upstreamed. So if you're interested in trying out Rust or Bazel, the documentation is not there. There's very little, but we would be delighted to get you going, for sure. Okay, last section. This section was much, much longer before. It is called EVerest to homogenize the fleet. And what do I mean by that? So these are our babies. this one and the first generation, but we actually also acquire charging stations outside, like basically to enter market mostly, or because sometimes if you win a tender, you have to take over third-party stations. So there's different strategic reasons why we actually also have a bunch of third-party stations on our backend. And let me tell you, it sucks to have third-party stations on your backend if you're used to working with your own hardware, right? And actually, just roughly maybe 5 months ago, that was the point when we lost it. We acquired a charging station, and now I have to treat carefully. Like as I said, this was much longer. But we acquired a charging station outside of Germany, actually roughly 50 charge points. And the hardware was okay. The software was like terrible. And that was not the first time, but it was the worst case that we had. We had literally every day, we had like to deal with outages, we had to deal with software issues. Then we had to like basically hack workarounds into our backend to deal with this particular place of hardware. And we already had in the back of our minds that we wanted to run EVerest on everything, right, on this one, on the first generation. And we also want to run it on as many third-party chargers as possible. Why? Because the least amount of software that you have that you need to support, the better, right? Actually, supporting different hardwares is not that bad, but like supporting different stacks of software is actually pretty painful. And I think actually Marco put it really nicely in his presentation, right? Like if you actually have like this cornerstone, the charging station, if that only has one interface, your life as a backend operator and is like significantly improved, right? So what we actually started doing, and we kind of became like the habit into, is that whenever we get like a new third-party charger onto our backend, we hack it. So we try to actually figure out how does it work internally, can we actually get access, can we install on our own software on that, right? And what you very often find is like a similar setup. There's usually, like there's some sort of charge controller, which is very often not the main compute unit. It's sometimes a very dumb component, very small, very cheap, right? Sometimes also off the shelf. And then what you very often find is that people put like a Raspberry Pi or a similar compute device into the charger, and then they put their software on there in like a write-only mode, right? You write it once, you put it out into the wild, and then good luck. And what we actually started to be doing is that we reverse engineered what is going on here, right? Which is not hard. Those protocols are very easy to understand, and there's always the same stuff, right? Like you know what is happening between here and the car. So this is usually not very complex. It's also like this is also where all of the mission critical stuff is happening, right? And then what we do is we write a BSP. So like I don't even know what is BSP standing for. Base support something. Board support package. That sounds right. Let's go with that. And that's actually like the lowest level hardware component in EVerest, right? Like that talks to the RFID card reader, that talks to the hardware, that talks to the charge controller. And then we ship this, and then on top we just put the same EVerest stack that we're also using for our devices, minus some components, right? Obviously you don't have the payment terminal usually, you don't have the nice display, you don't have the parking sensors, but it's like literally the same software package that we already know that we can support, right? And then we put this on the charger, and then we operate these chargers, and suddenly all of the pain that you have from really poorly written OCPP packages or like update support and so on go away, right? And that's actually how we like achieve to running quite a lot of chargers with like a lot of hardware diversity with a fairly small team and still achieve pretty decent uptimes. So again, this is kind of a teaser, right? We started this project like roughly 3 months ago, and now we have it ready for the first of the devices on our fleet, right? And we will roll this out into specifically this hardware that I don't really want to mention in the next couple of months, or actually weeks. And with that, we are actually at the end. Obligatory, we are hiring. We are always looking for great engineers. So if your current job sounds boring and you actually want to work on open source with really awesome hardware, come to us. Thank you very much.
I think Marco was volunteering.
And I would love to field any questions you might have.
Any questions?
With Rust in EVerest, where do you see that going? Expanding in new modules, writing alternative choices for existing modules in Rust? What's the future looking there?
Right. So, like, what we're having running here now is basically the EVerest framework and some of the EVerest modules that are part of the open source offering, which is all in C++. Everything that we do is Rust, like literally everything else, right? So also the BSPs that I mentioned that we are writing for the third-party chargers is all Rust. And we actually have made the experience that it's very quick. Once you know what you're doing, it's very quick to actually write new modules in Rust. So we will keep pushing that, right? And we will put out a lot of these devices. For the next 10 years, Qwello will be using EVerest with Rust, right? And for your questions, where do we see this going? That's always a little difficult, right? Actually, the contributions that we do are obviously also all in Rust, right? For example, the payment support module that we put out there, that is Rust, right? It's a Rust implementation, all open source, all Apache 2, so you can use it. We actually ran into one snag with the Modbus, how's this called? Lib Serial Manager, something like that. So there's like a EVerest module that actually like sits between you and the real Modbus, right? Like the Modbus is a bus that can contain many hardware devices, and only one piece of software can speak to that one because only this one piece of software knows actually which hardware device currently must reply. So everybody else who wants to talk Modbus, any other EVerest module has to kind of go through this particular module. And we actually, we made like experiments rewriting this one in Rust, which actually we like better because it's like our implementation is fair, it's like queue-based, it's async, it's a little more performant, but it's also much shorter. And it's reusing a open source Modbus library, which we actually trust more than the one that's in the EVerest code base at this point in time. And we are kind of hesitant if it would make sense to open source that, right? Because then you have kind of two different like implementations out in the open world. And so we haven't made up our mind about this one yet at this point in time. So basically, to summarize on your question, right, the future of Rust and EVerest is very bright. We will keep pushing it, and we actually also believe it's a good choice. But obviously, there's always a trade-off, right? We don't actually want to kind of cannibalize and like fork the ecosystem, right?
Any other questions? Don't see any hands. Nope. Then thanks.
Doesn't seem to be the case. So thank you very much.